Today let us discuss about volumetric analysis. Analysis are two types, quantitative analysis and qualitative analysis. Volumetric analysis is a quantitative chemical analytic procedure based on measurement of volume of reaction in a solution, and the method for volumetric analysis is known as titration. Advantages: it does not involve any tedious operation like precipitation, filtration, drying, and ignition, and is more rapid and more accurate. Titration: it is the measurement of volume of a solution of one reactant and that is required to react completely with measured amount of another reactant. One of the solution will be taken in a burette and another in a flask. The solution from the burette is added to the titration flask. Process of finding out the volume of the titrant that is needed for the reaction is and the method of analysis, that is volumetric analysis. This is a diagrammatic representation of titration. Now some essential terms to be known in volumetric analysis are molarity, number of gram moles of solute dissolved per liter solution, molality, the number of moles of substance dissolved in 1 kg of solvent, normality, the number of gram equivalent of the substance dissolved per liter of solution. These are needed for calculation purpose of volumetric analysis. Titrant, the solution of non-concentration, which is usually we are taking it in burette. Titrant or analyte is the solution to be determined. Now indicator, it is the reagent used to indicate the end point of a titration by bringing out the visual color change. It should have a clear and sharp color change, and it indicates when the reaction is complete also. Endpoint is the point in titration in which reaction between the two solutions just completed and at which indicators show the sharp color change. According to the endpoint, we are doing the volumetric analysis. Before you begin the titration, you must choose a suitable pH indicator, preferably one that will experience a good color change, close to the reaction's equivalence point. This is the point at which equivalence amount of the reactant and product have reached. Methyl orange, methyl red, phenolphthalein, methyl violet, bromophenol blue, litmus, bromothiamol blue, alizarin yellow. These are the common indicators that we are using, and its color change in acidic and basic medium are shown in the table, and its pH range is also given. These are the indicators. Now the choice of indicators is based on the type of titration. In case of strong acid and strong base, weak acid, strong base, phenolphthalein is usually preferred because it's more easily seen color change. In case of strong acid, weak base, methyl orange will be shown the color change equivalence point. In weak acid, weak base, neither phenolphthalein or methyl orange is suitable. No indicator is suitable because it requires a vertical portion of the curve over 2 pH units. Volumetric analysis can be further classified into acid-base titration, redox titration, and complexometric titration. Moving to the procedure, a typical titration begins with a beaker or Erlenmeyer flask. It contains precise amount of analyte and a small amount of indicator, and is placed underneath a calibrated burette containing the titrant. Small volume of the titrant are then added to the analyte and indicator until the indicator changes its color in the reaction, and it gives a saturation threshold representing arrival at the end point of the titration. It means the amount of titrant balances the amount of analyte present according to the reaction between the two. These are the common instruments used: a pipette, a calibration mark, calibrated mark pipette, beaker, burette, conical flask, and a graduated volumetric flask. This is an example. In the conical flask, we are taken a HCl analyte and NaOH is in the burette. and the reaction is noted, and there's just a graphical representation. Now, how we are estimating the equivalence point? The resulting solution at the equivalence point will have a pH dependent on the acid-base relative strength. You can estimate the equivalence point pH using the following rules. A strong acid will react with a weak base to form an acidic solution. Strong acid will react with a strong base to form a neutral solution. A weak acid will react with a strong base to form a basic one. This is a graphical representation. In initial phase, then before an equivalence point is there, at equivalence point and after equivalence point. The graph will grow like that during the volumetric analysis. Thank you.